I would like now to welcome Neha and her panel to the stage.
Good morning, Kafka Summit. I hope you had an excellent day yesterday and are looking forward to more amazing content. As you can see, I changed it up a little bit this year. And how could I not? I could attract these amazing panelists to come here and discuss some interesting questions with me. And not just any panel, but a power panel. Who do I have here? I have the CTO of Microsoft and my mentor. I have Martin Kleppman. His book is amongst the top 5 books on Amazon under computing. I have my co-creator of Kafka, my co-founder, my friend, and Slack's infrastructure boss. Now, I don't think we should get into any more introductions than that, so let's get started. I have Jay and Kevin here, and I'm not sure many of you know that Kevin was head of infrastructure at LinkedIn back when we created Kafka. So I thought, what could be a better start than really having them walk down memory lane and reflect on Kafka's origin story? And no, by that, I don't mean the usual, why in the world did we name it Kafka part? But really, or what?
We've already answered that one.
Yes, we already answered that one. But really more about, I think people are in the audience here. They want to know, what does it take to create another Kafka? How do you create a successful technology like that and one that becomes ubiquitous? So Jay, why don't we start with you? Why did we open source Kafka? And can you share the recipe for creating another technology that goes on to become so ubiquitous?
Well, we had a number of open source projects, and not all of them became popular. So I don't know if it's a formula that works every time. Yeah, I mean, it was one of the things that we worked on that we probably had the highest hopes for. There was a lot of ideas floating around at that time. It was a time when there was a lot of problems around how you handled data and not that many off-the-shelf solutions. For companies like LinkedIn that were working at scale. And so we were in the habit of building these internal infrastructure layers. There was a bunch of interest in kind of the stream processing literature. It seemed kind of weird that all the cool analytical processing happened like at the end of the day.
Right.
For a digital business, it was kind of like the end of which day. That didn't really make any sense. And so we were trying to think of like why had this academic literature not really caught on in the world, and we kind of felt like, hey, maybe the problem is people don't actually even have a way of getting access to the streams at all, and that was part of it. And then we looked at the architecture of distributed databases, and they had this kind of log-oriented structure, and that showed up in the stream processing literature, and it just kind of kept recurring. And then we were facing a lot of the problems ourselves, like there was an interest in these kind of data-driven applications. There was all the data pipeline problems, and so that kind of led to the creation. We had kind of a series of different technologies, some of which were kind of always falling over and needed to be replaced. And so that was how we started the effort. And then it took a lot to actually bring it to scale. It didn't work that well at first. It took a lot of effort to really make it something that could be trusted for critical applications and really scaled across the company.
I completely agree with you, and Kevin, I'm sure you will know, or you should share from a business perspective. As Jay mentioned, we had a couple systems to do, ETL into Hadoop and database change capture back at LinkedIn. So from a business perspective, why did it make sense to fund Kafka, and more importantly, why did you allow us to open source it?
Yeah, I mean, so those I think are really, they're almost two separate questions. And so on the latter, like why did we decide to open source it? So that was something that Jay was pushing for alongside his boss at the time, Igor Perisic. Yeah. And like Igor has this really great post on LinkedIn about like why LinkedIn became an open source first company, like where just sort of by default, like if you were doing something there, and like this is still true today, that you come to ask someone for permission to open source it, the default answer is yes. There has to be a good reason not to open source it. Now that doesn't necessarily mean that everything you want to open source is it's a good idea to open source it, or that moreover, if you do open source it, it is going to become a successful thing. But like it was just sort of an easy decision for us. Like it was the way that we attracted great developers to the company. Interestingly enough, it was like one of the cool pieces of marketing for me joining LinkedIn in 2011 before the IPO, because at my startup, AdMob, we had used Voldemort, which was a key value store that Jay.
Finally, we find someone who uses Voldemort.
Yeah, and so like we at some point had been looking for a key value store, and like we evaled a whole bunch of different stuff, and like we decided that Voldemort was the best thing, and I'm like, because it was open source, like we got this visibility inside of LinkedIn's engineering team. We're like, wow, these guys are like pretty cool, and like that had always stuck in my head as like I was sort of navigating my own set of choices about career. So like everyone should just go read Igor's post, because he sort of describes all of that. From a business perspective, like why Kafka made sense is, and this is something that I think every great engineer ought to be, or everyone who aspires to be a great engineer ought to be looking for as much as possible. So like what Jay described was like this sort of ecosystem, both inside of the company with things that we had built ourselves, as well as outside of the company. And third-party products is this sort of convoluted, complicated ecosystem of technology for moving, moving data streams around from one place to another. We had at least a couple of other things that we had built at LinkedIn to sort of power bits and pieces of our distributed data infrastructure. And what Kafka like really did amazingly well is it sort of figured out the simplest, most elegant way to express the general problem in terms of, like in a way that would allow us to sort of not only solve like these other sort of like distributed systems application specific terms, but like what it's done inside of LinkedIn is just ridiculous, like how robust the internal data ecosystem is because of Kafka. There are tens and tens of thousands of producers of data, and like on the other side of that, like thousands of different consuming applications that do like a ridiculous variety of things. And so the reason that exists is because like Kafka is such a powerful and simple expression of a general idea. And so like when you see one of those, like as an engineering leader, like just invest. Like they're super rare, like MapReduce and some of the things that we had invented at Google, and like they are reliably like the best technology investments that you can make.
Wow, thank you for sharing that. In the same context, like you said, Kafka is used in a variety of different ways, right? And I remember that there was another transformation happening at the same time at LinkedIn when we were working on Kafka adoption, which was really us moving to microservices, breaking big applications into small little ones. You led us through that whole transition. So tell the audience what it took for LinkedIn to be successful. Like, was it painful? Was it easy?
No, it was super hard. For a whole bunch of like technical and cultural reasons. Like the technical reasons were, sort of harmless, I guess. Like there's it used to be a trend. Around so LinkedIn was founded in 2003, and so at the time, like it was completely typical for folks to build intranet technology stacks using something that looked very much like a LAMP architecture, or like sort of an enterprise database architecture where you've got a monolithic app and a monolithic database, and you sort of get started that way because it was the easiest way to get your minimum viable product out. But like as we all know now, like that doesn't scale, and the transition from the sort of set of technology decisions that you have to make to like build things that way to like building in a microservices way are difficult but tractable. You just sort of have to have the willpower to like go do them. And like where you get the willpower is like having, just sort of this culture of thinking about things. And like I think maybe the single hardest thing to do about that transition is like you have to think about every service in your microservices architecture is like a unit of accountability. So like you create it, you have to own this thing in production. You have to own the fact that people are going to use it in ways that you really hadn't intended. You have to basically get over this notion that you get to sort of vertically own your entire stack of services, and like you get to sort of control it in this very sort of waterfall-y, like monolithic way. And like that mindset, like getting past it is like a little bit difficult. It like feels scary to you. Like if you're used to being in control of everything, it can feel burdensome to you because like, oh crap, like now I've got this thing that I've got to carry a pager on, or like somebody's got to carry a pager on. I'm going to get like called at 2 a.m. on a Saturday night because it's down. And it sort of challenges your decision making because not everything should be a microservice. And so like lots of people, when we began doing this, would create these like pathologically bad microservices, not sort of accepting that it was like a unit of accountability. They're like, oh, this is easy to create. And at one point, you guys remember this very well. Right around the time of the IPO, we had more services in production at LinkedIn than we had engineers.
That's right.
It's just nuts.
I think it took a while to realize that wasn't good.
Yeah, yes. No, it's very much not good.
Not recommended. So not everything should be a microservice. Julia, as head of infrastructure at Slack, what do you think? Like, are microservices for everyone? And does Slack subscribe to that?
So I think it always depends, and it depends upon what you're building. And I think what Kevin highlighted on the culture that your organization has. So Slack is only about 5 years old, which is not that old, and we still operate a very large, was PHP, is now hack monolith. My organization runs a lot of services. I wouldn't necessarily say microservices, but I would say first-class services that the monolith connects to. And for us to understand how to bring those services to maturity, how do you tune it? How do you monitor it? Who carries the pager for those services? That's us starting to dip our toe into, okay, what does it mean to really own and operate services at scale? I think for a lot of reasons, our monolith will probably be around for a while. The founders of Slack, who I work very, very close with now, they know how to run PHP at scale. And our chief architect, Keith Adams, came from Facebook. We're now using HHVM. We know how to run this technology. At the same time, hopefully most of you in the audience, hard to see, but how many of you know what Slack is? How many of you use it? Okay, thank you, I appreciate it. Hopefully it's working fast for you today.
More than we'd like.
If it's not, you know who to come to. So a lot of the interactions within the product, they're very tightly coupled to each other. And so what that means is that when we've thought about potentially splitting the monolith, there's not a lot of services that we've quickly identified as being able to split out. So when you're interacting, switching workspaces, going to different channels, searching for users, some of that, there is some services you're connecting to, but largely there's a really tight coupling, and that doesn't yield to us like orthogonally splitting that monolith apart. Now, who knows what the future holds? Like potentially we might do that in the future, but for now we're operating a very small set of services. We're understanding how to, again, deploy, tune, monitor those services at scale, and then we'll see what happens.
Yeah, and you brought up that point, right, about the integration, right, between these different services. And so, Martin, you had a really good talk here. Is Kafka a database? So in the context of microservices, right, traditional NTR architectures, we've just treated the database as the sole integration point, right? That's where the state goes. So as you start to break these monoliths into microservices, as they start to become more like stateful and event-driven, like how does the role of the state store change? And what is the relationship between databases and stream processing then?
Yeah, that's a really good question. I think often, like if you're building services and those services are stateless, then basically life is easy, and so
That's right.
no problem, right? So the difficulty is in handling state. And moreover, if each microservice has its own database and it's a self-contained vertical slice, and when data of a particular type needs to be stored, you always go to that particular service and it just goes into that one database, then again, that's quite manageable. So where I feel the difficulties start arising is if maybe several services need access to some data. And you could have them querying each other all of the time, but that can start getting rather slow. So you might then end up having a copy of some data in two different services' respective databases. And that's then a place where I feel stream processing can come in, because like if you're doing REST calls between microservices, that works quite well for read-only requests. But if you're doing writes, well, we have all of the problems that I was talking about earlier in my talk. Like you can have writes that succeed in one place and fail in another place, and now you've got a consistency problem. And so there, I think stream processing can really help by providing a kind of reliable pipe for transporting writes from one part of the system to another. So you can initially write something in one place, but then be sure that everyone who wants to know about those data changes, they can subscribe to the appropriate stream and be notified about it.
So there's this question that comes up pretty frequently. We get asked that. I'm sure Jay, you should weigh in. Is how when it comes to request response architectures and event-driven architectures, like does the event-driven architecture and where stream processing comes in, does it replace your request response? Is that really the the future that people are marching towards?
Yeah, no, I think these things both need to exist, right? Like it almost depends on the problem in the business that you're trying to solve. And so, if you have some user experience that's very much request-driven and synchronous, then that's probably going to trickle down to the technology you build. If you think about how a lot of businesses work out in the world, there's actually things happening in reality which take time and they're asynchronous. And if you think about the technology that results from that, it typically takes on this kind of event-driven path. Or it doesn't, and it gets kind of, pigeonholed almost into a request response paradigm, which can actually be really fragile and hard to make reliable and correct. And so I think if you see, companies as they grow, often a small company will really just have one of these things. But as it gets more rich and the functionality gets richer, I think you always end up with, some amount of both of these things. It's very rare that everything is all one. In some sense, a lot of the early web companies, I think, were very request response heavy because they were ultimately doing some kind of CRUD. If you think about how does a bank operate, I think it's a lot less UI, right? There's a lot more happening kind of in the background in response to the interactions with customers, the trades, whatever the back end of that system is doing. And so I think these paradigms kind of naturally fall out. And if you talk to people who work in different companies, they often have in their mind some way that things work, right? And when people try and talk to each other, they often can't communicate because they're so locked in the paradigm that they come out of.
Right.
I mean, I think one thing to add there is, in a whole lot of ways, the pattern is sort of similar to the monolithic web app versus microservices decisions, and like a lot of this is just sort of about scale and simplicity. So, like as you scale, like microservices is like absolutely the right way to solve like your overall architectural problem, and like the question of like how soon do you start going there is a matter of how simple are your abstractions for building microservices. The same thing is true for data systems. So like at the smallest unit of scale, like the easiest thing to do is solve your problem with a monolithic data store. But the things that Jay and Martin are describing are like it's just unquestionably the way that you scale data systems is to like break things apart and like have these sort of message systems sitting at the core of them. Like if you look at a database architecture, like that's the way that they're, that distributed databases are built. And so like it's the right and natural thing to sort of like pull things apart, the same way that you pull your monolith apart into microservices. So, like I think, you like really should be thinking about, when, not if, with these sorts of things.
Yeah, that's
especially
a great
as
point.
like, the universe of data explodes.
That's right. That's right. So switching gears a bit, there's a lot of talk happening in the community about open source licensing, right? And there's an obvious tension between open source, companies and creating, like Confluent, that create the software, give back to the community in a big way, and on the other hand, public cloud companies that resell open source software, and often without contributing much back, right? Kevin, you've been on both sides of the equation, right?
Yeah.
At LinkedIn as the sponsor of open source, and now at Microsoft.
Yep.
How do you think this is going to play out? So in the end, the community continues to thrive and wins.
Yeah, look, I think over time, and you can sort of certainly see this with Microsoft, is that there's just a set of natural benefits for open sourcing data infrastructure and participating in open source communities. Like the most powerful reason you do that is because that's what developers want. It's just pure and simple developer choice, and like it's the right thing to do to serve your developer customers to sort of be involved in these open source communities, like as a productive, positive member of their communities. The thing with like folks who actually have public clouds, like you're sort of selling cloud services, like. I think there's natural alignment there actually, and like people may just not have realized it yet. But like Microsoft, for instance, like we have this big partnership with Databricks, and like that is a great thing for Databricks, which is a company that services the open source Spark community, and it's a great thing for us because like the thing that clouds care about is like you're on the cloud developing on the platform, sort of consuming all of the resources that the cloud provides. Like what the actual software is that you're running on the cloud, like you should be natively providing things like as the cloud provider because like there are holes in the ecosystem and like you can see the future, like you want to like provide useful tools for folks. But like where there's an open source thing, like absolutely you should provide it and like provide it in a way where you're contributing back to the community, and like we should be friendly with all sorts of companies like Confluent.
So Julia, from a Slack perspective, how do you think open source licensing and it evolving plays a role in Slack adopting open source software? Does it matter, or does the community matter?
So we use a lot of different open source technologies. For example, if you use the desktop application, we use Electron to develop that. Obviously, Electron came out of GitHub and is now at Microsoft. We're very, very active in that community. As very heavy users, again, at scale, deploying quickly, we have to have a really tight relationship with not only the current roadmap, but the future roadmap. And part of that is us contributing upstream. Another example is Vitess. So Vitess is an open source technology that came out of YouTube to heavily scale and shard MySQL. So behind the scenes, Slack is a MySQL shop. We're, again, very close with that community. We've pushed a lot of patches upstream. We're working very closely with the company that spun out of YouTube to then productionize Vitess and potentially sell services with it. So again, we cannot operate technologies at our scale without that direct relationship. And I'll talk a little bit, too, about often some of the technologies we're using. For example, I had talked before about Hack and HHVM. Some of those technologies were developed in places that had fundamentally different infrastructure because they came of age at a different time. Like, obviously, the Facebook infrastructure is very different than the type of infrastructure, at least right now, that we're running at Slack. The same thing for Google. A lot of great stuff that has come out of Google is based heavily on Google's internal infrastructure. And since we run different infrastructure, since we might use a different containerization strategy, we are going to have to change and modify some of those technologies. technologies. And the only way that we can do that successfully is to have that relationship with the community. And then ideally, the next company that comes along that might be completely cloud native, running in the public cloud, they'll be able to take advantage of some of the patches that we've pushed upstream and the influence of thought that we've had with those communities about how do we then take these technologies and apply them in totally new places. We use Kafka, big users of Kafka internally. We really love it. And there's a lot of different new and interesting use cases we're exploring with Kafka that probably, we didn't even exist when Kafka was in the genesis of Kafka. And so I think it's really exciting to think about the ways that these technologies can be used. But all that is very predicated on having the relationship.
Mm-hmm. That's great. So switching gears a little bit, Martin, in your book, you explore a lot of the foundational building blocks, right, of data infrastructure, how things come together, right, to build data-intensive applications, right? Looking into the future, in the next 2 or 3 years, also some startup ideas here, like what do you think is missing? What are we going to see in terms of gaps?
Yeah, so there's one thing that I hope that somebody will do. So I feel like something like Kafka gives us something like a 21st century equivalent of the Unix pipe. So it gives us some mechanism for getting some data from one thing to another thing and to tie those two things together, and it provides a common interface that allows very different types of systems to talk to each other. And what I don't see yet is the things built on top of that. So what is the 21st century equivalent of the Unix shell? Like, we have the pipe, but we don't yet have a way of quickly and easily plugging things together in a way that they just slot together in the same way as you can do grep pipe, awk pipe unique, and such like on a Unix command line. So that's something I think a lot about. Related to that is, like, I see a lot of opportunity in moving away from the request-response model that we so used to it from HTTP that we send a request, we get a response back, and then what? Like, if the data changes on the server, don't you want to be notified? Because like the thing you just got in the response is outdated by now. So really what we want to move towards is a more publish-subscribe paradigm where you can query the state at some point in time, and then afterwards, you just keep listening for updates if that state changes. It seems to me like should be a very natural way of building systems, but the request-response way of thinking is so ingrained in all of our libraries and all of our programming languages that moving...
And even in things like front-end frameworks, right?
Absolutely. I mean, like what I see exciting is like tools like React, for example, kind of have a bit of this notion that you're getting state updates, which may be coming from a server or maybe coming from the user's own local input, which updates some state, which is then re-rendered in the user interface. So we've kind of got a bit of a stream flowing there on the user interface side, and we've got streams flowing with Kafka on the server side, but there's still quite a gap between those two. Like, what is the programming model in between those two? And that is, I think, something that's going to be really important in the future, and maybe one of you will figure out.
We're starting to transition from, so if you use Slack on a desktop computer, we open a WebSocket and we send a lot of data back and forth. We then transitioned to more of a request-response model, but the ultimate place that we're going is publish-subscribe, and we're starting to use React. And the ability to scale our services and scale our product with that type of model is substantially better. Yeah. But it's a very different type of technology, and it requires a different culture, too, for how you think about, how you do development, how you debug it, all of those things. So
Absolutely.
Yes, it's the future.
Yeah, and in an interesting way, like it can even, like if you do it right, it can eliminate complexity. Like you can sort of get rid of most of your mid-tier or like all of it, and like nobody loves mid-tiers.
So with some of you here, I would personally like you to speculate on the future a little bit. If you look just 5 years in the future, what is hype and will die down, and what are things that will live on? As a developer, what is my experience going to look like when it comes to data technology?
Who do you want to start?
I would love for you to start.
Yeah, so, I think like you all are sort of in the right place talking about the right set of technologies right now, because we were talking about this backstage. Like one of the things that I think we're all going to see over the next few years is the next emerging computing platform is really IoT. And we already have like something on the order of 12 billion IoT devices connected to the internet. And Gartner and our own internal data says that that's probably going to start increasing by about 10 billion devices a year with perhaps some acceleration. And so as you get this sort of ubiquity of IoT devices, like these sort of connected things that are everywhere, they do most of their work by sensing the environments that they're in. And what that means is like a huge amount of additional data. So like if you think about the thing that's made the web work, sort of really well, just sort of in terms of this data, machine learning, sort of engagement data loop that we've got right now. Most of the data is coming from, how all of us are engaging with internet products. But pretty soon, you're going to have maybe orders of magnitude more data than we've ever created, as hard as that may sound, because it's coming from these high bitrate sensors that are in this ridiculous proliferation of devices. And, I think streaming sits at the very center of the application architectures for these things. Moreover, you're going to have, there's just several orders of magnitude improvement in AI inference capabilities. So how cheap can you do, can you run a ResNet 50 model to do computer vision? And sort of turns out in a few years it's going to be pretty cheap. You'll be able to, for 50 cents, put a chip on a consumer grade price. It'll be able to run those models and sort of transform a high bit rate raw video stream, for instance, into a semantic stream of AI events. And so I think your life as a developer in the future is very likely going to look a lot like where many of you are right now on the cutting edge, where you've got microservices, but they're running in some device that's sort of sitting out at the very edge of the cloud. They're going to be doing inference, but the inference is going to be taken care of for you by the environment, and you're going to be writing these applications where you're manipulating data streams, and sometimes it's going to be streams of sort of AI inferences that you're building your apps on top of. So that's sort of my 5-year view of things as it relates to this part of the world.
Very interesting. So Jay, at the end of Martin's talk, he showed that we have almost the foundational kind of building blocks of what a database entails. Speculate on the streaming database. Is that a thing that we will get to see in the future? Will all those building blocks come together as a streaming database? And then what happens to the relational database then?
Yeah, I think that's a great question. I think we're actually seeing kind of the emergence of really a whole new platform here, and it's kind of coming from the bottom up. We have the building blocks. It's really just now getting to large scale deployment in a lot of companies in different areas, and whole new things become possible and whole new problems arise. We were talking about this backstage that LinkedIn had all this data that was available through these Kafka streams, and suddenly there was all those new problems that were created as a result of that, and new tools that came on top of that. And I think that's one of the most exciting things in this space, is kind of seeing how this plays out as different companies really move towards this in different industries, and what does it do to how a bank is built, or how a car company operates as they suddenly have these sensors in all the cars, and what happens in the insurance industry. I mean, you can look across all these different types of companies and how they operate, and how does this technology play out. And I think we are seeing this kind of blur from the stream processing space. As you're getting the ability to represent the evolution of tables of data and put that together with kind of the events and what's happening in the world, and really build on top of those abstractions at a much higher level. It is starting to look a lot more like a database, depending on what the definition of database is. I have no idea how these things play out. Usually technologies never really go away. right? And so I think the focus for this ecosystem, I think, is very much this kind of event-driven space. I don't think it means all the other things disappear, but I think that's going to turn into this huge platform at the center of companies. And I think there's a whole ecosystem emerging around it, which is a cool thing to watch.
That's a great point and a good point to end the panel here. Thank you so much, Martin, Kevin, Jay, Julia. This was the best panel I've been part of. Thank you so much.